All right, so Pythagorean Theorem applications. I'm going to go through a few examples for my students. Some of these are going to be like the same question that students always ask in math class. Are we ever going to use that? Pythagorean Theorem you can use a lot. Now, I might be a little sarcastic in some of the ways that I'm going to present it in some story problems, like this first example. So a really common one that shows up in a lot of math classes, a lot of math problems, especially when you're learning it, is the house and ladder problem. So the house and ladder problem is, I have a house that's, let's say, 20 feet tall. So I'm gonna draw. Usually students will be getting this in a story problem form, and I always, when you're in math class, when you're in geometry class, you need to be drawing your problems, especially geometry. It really helps when you draw out your problems. So let's say the story problem read, you have a house, or the house is 20 feet tall. So I'm gonna say that this is 20 feet tall. And you have a ladder that is, I don't know, let's say 16 feet. So I have a ladder set up that is 16 feet. Draw my little ladder, and that's 16 feet. That can't be 16 feet, hold on. Hopefully everybody knows why I just made that mistake. The hypotenuse of a right triangle can never be shorter. It's the longest side. It can't be shorter than the other two. So let's make it 25 feet. All right. So the story problem has said so far, you have a house that's 20 feet and a ladder leaning on that house that is 25 feet. And then the story problem will ask you, how far away is the ladder, okay. How far away is the ladder from the bottom of the house? So that's this piece down here. Well, obviously, when you're out with your dad or whatever, you're cleaning out the gutter, you're doing some painting on the house, you're gonna pull out your tape measure and you're gonna measure this to make sure it's perfect, because that's what we all do, right? Yeah, being sarcastic. Probably wouldn't actually do this in real life. You would grab your ladder and you'd be like, oh, there we go, it's there. I'm gonna go up the roof now. However, this is a good way to learn how to use the Pythagorean theorem to actually solve something. So we don't know what this distance is. I am going to draw in where our right angle would be, and that would be right here. Assuming your house is not like the Leaning Tower of Pisa and is going to fall over eventually. Hopefully it's perpendicular to the ground. That's the goal. All right. So now we have to figure out, hopefully everybody can remember from the last video I made, which are the legs and which are the hypotenuse. Well, I kind of already talked about this over here is the hypotenuse, which means that over here I'm going to call this A, and instead of X, I'm going to call this B. All right, so now I'm going to go to the Pythagorean theorem, which is A squared plus B squared equals C squared. But I can substitute what I know in, and something I know is A is 20. So 20 squared plus, I don't know what B is. Can't do anything with that. I know what C is, and that's 25. All right. So now we're going to keep simplifying this. We're going to solve for B eventually. So 20 squared, that is going to be 400 plus B squared equals 625. Now I need to take away this, and I do it to both sides. So I get B squared equals 225. square root. That's how we cancel out a square, right? So let's square root both sides. Ugly. Nah, that's not pretty, but whatever. That cancels out there, and I get b equals square root of 225 is going to be 15. So we get 15. All right. So then when answering your story problem, you would answer the ladder is 15 feet away from the bottom or hopefully you got a multiple choice. I know my students right now, because of the school closure, have multiple choice. So they're just going to select the answer that has this in it. 15 feet. Now again, hopefully some of you guys have done some ladders, been on a ladder. Usually you want your ladder a little bit closer because you don't want your ladder to in, all right? So usually you bring your ladder a little bit closer so it's more sturdy. Yeah, it's pretty far out. I wouldn't be that far out probably. Now we're gonna do this one in a different way. I'm gonna leave the Pythagorean theorem there. Still gonna be the house and ladder problem. Just gonna be solving for something different. This one's actually easier. So this one we're just gonna have, instead of the hypotenuse, we're gonna have both legs. So what if the story problem says that your house, got a little crank going on there. Your house is, let's do meters this time. So let's say meters, 4 meters high. And you set your ladder 1 meter away from the house. So this time we're going to be solving for the hypotenuse, which we don't know. So we need to solve for C, because that, again, hopefully not Leaning Tower pizza. Your house needs to be up straight. So we're going to solve for that. So I have, didn't want to do that in blue. I have 4 squared plus 1 squared equals C squared. 4 squared, 16. 1 squared is 1. Add those together, you get 17. Then you come in here and you take the square root. Now, the square root of 225 simplified. We know that the square root of 225 is 15. However, 17 is a prime number. There is no square root of 17. Well, there is, but I don't want the approximated version. I don't want it rounded to 1 decimal. I don't want it rounded to 2 decimals. This is the answer that I would be looking for as the teacher. Now, your teacher might say round to 1 decimal, round to 2 decimals. Simplify. Well, this one also can't be simplified because, again, it's prime. So the answer that my students would be looking for is, how tall is the ladder? The ladder is square root of 17 meters. So the ladder is square root of 17 meters tall. And again, for my students, because we're doing multiple choice, they just need to select this one because that is the one that is going to be in their multiple choice problem. All right, not the decimal version. All right, let's move on to a different type of Pythagorean theorem application problem. A fun one, another common one is the shadow. So something casting a shadow in the sunlight. So beautiful tree, awesome tree, great. So we got a little sun over here. Bop, 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 bop. All right, it's casting a shadow. And we have this shadow that has been casted due to light onto this tree. All right, so you can measure, I mean, you're probably, again, never gonna do this in real life. I don't know why you'd go out and measure it. For one, you're gonna have to climb the tree to measure the tree, drop down the thing. It's gonna take 2 people. I don't know why you're measuring trees anyways. But it is a good way to learn how to use the Pythagorean theorem. So let's say that you and your friends decided to measure, well, a pine tree. You climbed to the top of it, you got your little tape measure, and you measured it straight down. And you found out that this tree was, let's say, 44 feet high. All right. And this one's easier. This one's more doable, as you measured the length of the shadow, which let's say is 82 feet. Well, then how long, or what is the distance from the tip of the shadow to the tip of the tree? So what is this? All right. Well, we are going to hope, again, for one, this tree's perfect. This tree's got no tilt. There's no wind blowing around this neighborhood. This tree's standing perfectly straight up, because we're going to make it perfect, and we're going to say that this is the right angle, which makes this not a question mark, it makes a C. So we need to find C. All right. So we're going to come over here, we're going to substitute in. We got 44 squared plus 82 squared equals C squared. All right, I'm going to have to bust out. Where did I put my calculators? I got everything put away. Don't mind me over here tearing up my room. All right. All right, I'm back. So, gotta get rid of some of this stuff in my hands. So we're gonna have 44 squared, because I don't know that top of my head. Whew, getting big numbers. All right, 1936 plus 82 squared, 6,724 equals C squared. Nice C. I don't know what's going on with that C. That growth spurt. All right, combine that. So we're gonna add those together. So 1936 plus 6724. So we're gonna get 8,660 equals C squared. All right, then you come in here, do your little square root. Do your little square root. So I'm gonna use my calculator, I'm gonna find out. Does this have a square root? I don't know. You get 93.0591, blah, 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 blah. Right? I don't want this. I want this. This is the exact answer. The exact answer is a square root. Square root of 8660 feet. All right. I do not want an approximation. I want the exact answer. The exact answer is this in feet. Now again, some of your teachers might want this rounded to 1 decimal, 2 decimals, right? If I was gonna round to 2 decimals, that 9 is gonna round that up, so it'd be 93.06 feet. But for my students need to be answering with this. All right, that's the exact answer. I don't want it approximated, I don't want it rounded. That right there. All right. I'm gonna do one more one more application problem. I like this one. This one applies to a sport. You can do all sorts of sports. Actually, I'm gonna do another one. So my students have a problem that's baseballs. I'll just draw it really quickly, so maybe they know how to draw it. Right, I got my base out here, got my base over here, base over here, I got my diamond. That's 90 feet, that's 90 feet, that's 90, that's 90. And then you can ask a question of, if the catcher wanted to get somebody out at second, how far would they have to throw? Well, that would be the right triangle, and this would be C. All right, or another one could be, how far does first baseman need to throw to get the ball to third base? And again, I'd just be like, okay, well, there's my right, so that's C. So 90 squared plus 90 squared, find the square root. I just thought of another one. You could do volleyball, all right? I'm gonna do a failed attempt at volleyball, but let's pretend that's the volleyball net, right? We're dreaming here, that's the net. Put it in there, we got the net. Let's say we have, we got this spiker. Let's say this is the ground, by the way, because you know when you spike, you jump up into the air. Let's say they're hitting this ball, this volleyball. I don't know what volleyballs look like. I mean, other than the fact that they're a sphere, I don't know what lines you got. All right, and they're gonna spike it to the ground. All right, well, let's say that they spike it when they're 10 feet in the air, and it hits the ground, let's say 13 feet. So this distance to this distance, 13 feet away from them. How far was the ball spiked? C. So you come in here, you put a little right angle to make it a right triangle, and you're gonna have 13 squared plus 10 squared equals C squared. And you go through and you solve it. There's a lot that happens in the world that can be represented by a right triangle. Do we do that for everything? Probably not. Is it a good way to learn it though? I think yes it is. So you go through, you're gonna get 169 plus 100. Add those together, you get 269. Hopefully everybody knows that there's not a square root of 269. So the answer would be square root of 269 feet. All right. So hopefully that helps my students with their application problems that they have assigned today, and anybody else watching this video. Thank you for your time.